Welcome, everyone, to another deep dive.
Hmm.
We love to pick a fascinating topic and really get into it.
Absolutely.
And today we're diving into something that I think is really important,
Mm,
but often gets overlooked in the rush to build amazing web applications.
I agree.
And that is performance optimization.
Yeah. It's so easy to get caught up in the features and the functionality
Right.
that we sometimes forget about the impact of all that on the user's experience.
And it's not just about making things a little bit faster.
Yeah,
We're talking about a fundamental shift in how we think about building for the web.
absolutely.
So for this deep dive, we've got a ton of great material to dig into. We've got excerpts from some really interesting research papers, articles from leading web developers, and even a little peek into the history of the web to see, how we got to where we are today.
Sounds fascinating.
Yeah, I think it's going to be really eye-opening.
I'm looking forward to it.
So let's jump right in. One of the things that struck me as we were preparing for this is just how much the web has grown. Like, it's kind of mind-boggling.
It really is. I mean, think about it. The average web page size has increased by something like 600% since 2012.
600%. That's insane.
Huge. And it's not just about the sheer amount of data. It's about what that means for users on different devices with different connection speeds.
Right.
We can't assume everyone has a super fast fiber connection and a top-of-the-line device.
And that's where performance optimization becomes so critical.
Exactly. We have to make sure that our web applications are accessible and usable for everyone.
Regardless of their context.
Right.
So I guess the first question is, when we talk about performance in the context of web applications, what are we really talking about?
Well, it's not just about making things load quickly, although that's certainly part of it.
Right.
It's about creating a seamless and responsive experience that feels as smooth and fluid as using a native desktop or mobile app.
So it's about that feeling of immediacy.
Exactly. Users have come to expect that level of responsiveness from their software, and the web is no exception.
So how do we even begin to measure something like that?
That's where things like Google's Core Web Vitals come in.
Core Web Vitals.
Yeah, they provide a framework for understanding the key aspects of user experience that contribute to a perception of good performance.
Okay, so what kind of metrics are we talking about here?
Well, there's a largest contentful paint, or LCP,
LCP.
which measures how quickly the main content of a page becomes visible.
Okay, so that's like the first impression.
Sort of. It gives you an indication of how long it takes for the user to see something meaningful on the page.
Makes sense.
Then there's first input delay, or FID, which quantifies how responsive a page is to user interaction.
So like if I click a button or try to scroll, how long does it take for the page to actually react?
Exactly. It's all about that feeling of interactivity and responsiveness.
And are there other vitals that we should be aware of?
Oh, absolutely. There's first contentful paint, or FCP.
FCP.
That measures how long it takes for the browser to render the first bit of content from the DOM.
Oh, okay.
There's interaction to next paint, or INP,
INP.
which is a newer metric that aims to capture the overall responsiveness of a page to user interactions.
Okay, so kind of a more holistic view.
Right. It looks at the entire life cycle of the interaction, not just the initial delay.
I see.
Then there's cumulative layout shift, or CLS, which measures how much the layout of a page shifts unexpectedly during loading.
So like when things suddenly jump around and you lose your place?
Precisely, it can be really disorienting and frustrating for users.
Definitely.
And finally, there's time to first byte, or TTFB,
TTFB.
which measures how long it takes for the browser to receive the first byte of data from the server.
So that's more about the initial connection.
Exactly. It gives you an idea of how responsive the server is.
Okay, so these core web vitals, they sound pretty technical, but why should the average person care about this stuff?
Because they directly impact your experience as a user.
Yeah.
A website with poor core web vitals is going to feel slow and clunky.
Frustrating.
Exactly. You're more likely to get frustrated and abandon the site altogether.
And I know from my own experience that if a website takes too long to load, I'm out of there.
Right. No one wants to wait around for a slow website.
And it's not just about user experience. These metrics actually affect your search ranking.
That's right. Google uses these core web vitals as part of its algorithm for determining search results.
So if your site is slow, you could actually be penalized and lose visibility.
Absolutely. It's becoming increasingly important for website owners and developers to prioritize performance.
So it's not just about making things look pretty anymore.
No, it's about creating a fast and efficient experience that keeps users engaged and coming back for more.
So what are some of the biggest challenges to achieving that kind of smooth, near-instant experience we're striving for?
Well, one of the most persistent challenges is latency.
Latency.
Yeah, it's the delay between a user's request and the server's response.
Okay, so even if our code is super optimized, if there's a lag in that back and forth communication, the user will feel it.
Exactly.
It's like trying to have a conversation with someone over a bad phone connection.
A perfect analogy. It's just frustrating.
And that frustration can lead to users abandoning websites,
Yeah.
reducing their interaction.
Ultimately not completing the actions you want them to take, like making a purchase or signing up for a service.
So how do we tackle this latency problem? It seems like a fundamental limitation of relying on a remote server.
Well, there are a number of strategies that can be employed.
Okay.
One common approach is to use content delivery networks, or CDNs.
CDNs.
These are networks of servers distributed around the globe that cache content closer to users.
So instead of every request having to go all the way back to the origin server.
Right. The content can be served from a server that's geographically closer to the user.
So it's like having a network of mini warehouses for your website's assets.
Exactly. Strategically positioned to get things to the user as quickly as possible.
Very cool.
Another method that's gaining traction is edge computing.
Edge computing.
Yeah, this pushes the computation itself closer to the user.
Instead of sending data back and forth to a central server.
Right. Some of the processing happens right at the edge of the network, closer to where the user is.
And that can significantly speed up response times.
Especially for applications that require real-time interaction.
So that makes a lot of sense, especially as we move towards more interactive and dynamic web experiences.
Absolutely. We need to be thinking about how to minimize the distance that data has to travel.
Along with addressing latency, the way browsers handle data has also evolved to improve performance.
Oh, yeah, for sure.
The transition to HTTP2 and HTTP3 introduced some pretty significant changes, right?
It's been a game changer, really.
In what way?
Well, HTTP 2 and 3 introduced streaming capabilities.
Streaming.
Yeah, so instead of waiting for an entire file to download before anything appears, content can be displayed as it arrives.
So it's like getting a continuous feed of information rather than waiting for the whole package to arrive at once.
Precisely. And this can make a huge difference in the user's perceived loading time.
I bet especially with large assets like images and videos.
Absolutely. It eliminates that feeling of staring at a blank screen while waiting for everything to load.
So it's a much smoother experience.
Much smoother.
But even with streaming, we can still run into issues, right?
Oh, yeah, for sure.
Like what kind of things?
Well, even with streaming, certain resources can still block the entire rendering process until they're fully processed.
So it's like a traffic jam on the information superhighway.
Exactly. We call this render blocking.
Render blocking.
Yeah, and it can significantly slow down the time it takes for the user to see anything meaningful on the page.
So how do we avoid these bottlenecks and keep the data flowing smoothly?
Well, it all comes down to how we structure and organize our content.
Okay.
We need to prioritize the most critical elements that need to be displayed first.
So the things that the user needs to see right away.
Right, and then we can defer the loading of non-essential resources until later.
So it's not just about streaming itself.
No.
It's about strategically orchestrating the delivery of content to take full advantage of streaming capabilities.
Precisely. It's about thinking about the user experience from the very beginning and making sure that we're delivering content in a way that feels smooth and responsive.
And that brings us to another set of tools that modern browsers provide to improve the responsiveness of web applications.
Yes.
Web workers and service workers.
Powerful tools they are.
So what do these tools allow us to do?
They allow us to offload tasks from the main thread.
Okay, so instead of everything happening in a single line.
Right, we can delegate tasks to these separate workers that run in the background.
And that prevents those tasks from bogging down the user interface.
Exactly. The main thread is free to focus on keeping the UI responsive and interactive.
So these tools are like specialized teams working behind the scenes?
Yeah, a good analogy.
Freeing up the main team to focus on delivering a smooth user experience. Can you give us an example of how these workers are being used in practice?
Sure, a good example is PartyTown.
PartyTown.
It's a library that leverages web workers to isolate third-party scripts.
Third-party scripts?
Yeah, these are scripts that are often embedded on websites, but come from external sources like analytics trackers or social media widgets.
Okay.
And these third-party scripts can be a major source of performance issues.
How so?
Well, they often load a lot of additional code and resources.
Which can slow things down.
Exactly, and they can also block the main thread while they're executing.
So Partytown helps to mitigate those problems.
Right, by running these third-party scripts in a separate worker thread.
So it's like having a separate room for the party guests
I like that
so
analogy.
they don't disrupt the main event.
Exactly. Everyone gets what they need without stepping on each other's toes.
And that leads to a much more responsive application.
Precisely.
So by strategically delegating tasks and managing resources,
We can create a much more efficient and responsive web experience.
it's all about working smarter, not harder.
Absolutely. And when we talk about managing resources effectively, we really can't overlook the role of caching.
Caching, I mean, it's like having a shortcut for information that you need to access frequently.
That's a good way to think about it, yeah.
Instead of having to go back to the original source every time you need it, you can store a copy closer to where it's needed, right?
Exactly. And that can save a ton of time and bandwidth.
So caching can happen at different levels, I'm assuming.
Absolutely. It starts with the client side. Your browser will cache things like images, scripts, style sheets locally on your device.
Okay, so that's like the first line of defense.
Right. If the browser already has a copy of the asset, it doesn't need to download it again.
Makes sense.
Then we have server-side caching, where we can cache entire web pages or even fragments of content.
So it's like having multiple layers of backup.
Exactly. Making sure we can deliver content as quickly as possible, regardless of where the request is coming from.
I like it.
And when it comes to server-side caching, there's a whole array of strategies that we can employ.
Okay, like what kind of things?
Well, for content that changes dynamically, techniques like distributed persistent rendering or GPR and incremental static regeneration or ISR can be really useful.
DPR and ISR, those are a mouthful.
I know, right? But they're basically ways to cache a pre-rendered version of a page while still ensuring that any updates are reflected quickly.
So it's like having a snapshot of the page ready to go, but with a mechanism to refresh that snapshot when needed.
Exactly, striking a balance between speed and freshness.
I see.
Then for content that remains relatively static, like articles or blog posts, static site generation or SSG can be a very powerful approach.
SSG.
Yeah, with SSG, the entire site is pre-rendered into static HTML files.
So there's no dynamic processing involved.
Exactly, which means they can be served incredibly quickly.
It's like having a printed brochure. All the information is already there, ready to be accessed instantly.
That's a good analogy.
So we've got DPR, ISR, SSG. Are there other caching strategies that we should be aware of?
Oh, sure, there's server-side rendering or SSR and client-side rendering or CSR.
SSR and CSR, those are pretty fundamental concepts in web development, right?
Absolutely. They determine where the HTML for the page is generated.
Okay, so with SSR, the server does the heavy lifting,
Right. It generates the HTML for each request and sends it to the client.
which can be great for SEO and for providing a fast initial load.
Especially for complex pages.
But it can also add some overhead to the server.
Yeah, because the server has to do more work for each request.
On the other hand, with CSR, the browser is responsible for rendering the page.
Right, using JavaScript.
So the initial load might be a bit slower,
Potentially,
but it can be more efficient for highly interactive applications.
where the content is constantly changing.
So choosing between SSR and CSR really depends on the specific needs of the application.
Exactly. There's no one-size-fits-all answer.
And then beyond these core strategies, we have tools like Memcached and Varnish.
Ah, yes, the caching workhorses.
So what do these tools do?
They act as dedicated caching layers between the client and the server.
Okay, so they're like specialized refrigerators for web content.
Exactly, keeping frequently accessed data readily available for quick retrieval.
Very efficient.
Indeed.
So we've talked a lot about caching, but let's move beyond that for a moment and explore some specific web performance techniques
Sure.
that developers can use to build faster and more efficient websites from the ground up.
Sounds good.
We briefly touched on progressive enhancement earlier.
Yeah.
Can you elaborate on how that approach contributes to better performance?
Sure. Progressive enhancement is all about starting with a solid foundation.
Yep.
We begin by creating a functional core experience using HTML.
So that even if a user has a slow connection or an older browser,
Yeah,
they can still access the basic content.
that's the goal. The content should be accessible to everyone, regardless of their context.
And then we layer on CSS for styling and JavaScript for interactivity.
Right. Progressively enhancing the experience based on the user's capabilities.
It's like building a house, starting with the essential structure and then adding the bells and whistles later.
Exactly. Making sure that the house is habitable even before the paint is dry.
And this approach aligns nicely with the idea of HTML-first development,
Right.
which encourages developers to use the browser's built-in capabilities as much as possible.
Absolutely. We want to leverage the power of the web platform and avoid unnecessary dependencies.
So it's about working with the browser, not against it.
Precisely.
Another interesting technique is utility-first styling.
Ah, yes, popularized by frameworks like Tailwind CSS.
So what's the idea behind utility-first styling?
It's about using predefined CSS classes to style elements directly in the HTML rather than writing custom CSS rules for everything.
So it's like having a toolbox full of pre-cut pieces of wood.
Yeah, it's good
You
analogy.
can assemble them quickly and efficiently to build what you need without having to saw and shape every piece from scratch,
Exactly, and this can lead to smaller CSS files and more maintainable code.
which indirectly contributes to better performance.
Right, less code means faster load times.
Makes sense. And this also ties in with the concept of HTML for state management,
Yes.
where we try to manage the application state directly in the HTML,
As much as possible.
potentially reducing the need for complex JavaScript frameworks.
It's about keeping things simple and declarative, letting the browser handle as much of the heavy lifting as possible.
And speaking of shifting responsibility to the client, we talked about local-first software earlier.
Yeah.
Can you delve a bit deeper into how this paradigm shift impacts performance?
Sure. Local-first software is all about empowering the client
Right.
by giving it ownership and control of the data.
So instead of relying on the server for everything,
Right. Processing and storage happen primarily on the user's device.
which means that many operations can occur offline.
Exactly, resulting in a snappier, more resilient experience.
It's like having a self-contained ecosystem on the user's device.
I like that analogy.
You can perform many tasks without waiting for the server's permission or being hindered by a slow or interrupted connection.
Precisely, and this can be particularly beneficial for mobile users who often have to deal with intermittent connectivity, right? Limited data plans.
So even when there is a connection, communication with the server can be optimized
Absolutely.
to only sync essential data.
Right. Further reducing bandwidth usage and improving perceived performance.
Now let's talk about another technique that can significantly improve the initial loading experience.
Okay.
Partial loading.
Ah, yes, the art of delay.
So what is partial loading all about?
It's about strategically deferring the loading of non-critical resources.
Okay, so it's like packing for a trip. You prioritize the essentials and leave the non-essentials behind until you need them.
A perfect analogy, we want to make sure that the user sees the most important content as quickly as possible.
And then we can load additional resources as needed.
Right, as the user interacts with the application.
So techniques like code splitting allow us to break down large JavaScript bundles into smaller chunks.
Exactly, loading only what's needed for the initial view, and then lazy loading additional chunks as the user navigates to different parts of the application.
It's like having different zones within a theme park.
Okay, I like where you're going with this.
You only need to activate the rides and attractions in the zone that the visitor is currently exploring.
Exactly, not the entire park at once.
So there's a much more efficient use of resources.
Absolutely.
And there's also this new architectural pattern called islands architecture.
Ah, yes, islands architecture.
So what's special about islands architecture?
Well, it takes this idea of partial loading a step further.
Okay.
It allows developers to define interactive regions within a page
Okay.
and load their associated scripts only when those regions become visible or active.
So it's even more granular control over what gets loaded and when.
Exactly, further optimizing resource usage and improving performance.
Very cool.
It's a very powerful technique.
Now, in addition to all these techniques, we also have a whole ecosystem of tools that can help us optimize our web applications.
Oh, yes, tooling is essential.
It's like giving developers the instruments they need to diagnose and optimize their code.
Like a mechanic with their toolbox.
Exactly. So what are some of the tools that you find particularly helpful?
Well, there's Million.js.
Million dots.
Yeah, it's an optimizing compiler for virtual DOM libraries like React.
Okay.
It can significantly enhance rendering performance by minimizing the amount of work that the DOM has to do.
So it's like having a super efficient assembly line for building user interfaces.
Exactly, streamlining the process and reducing wasted effort.
I like it.
Then there's a Shrit Waiter.
Ultra Attack Waiter. That's an interesting name.
It is, isn't it? But it's a very useful tool. It helps to reduce render blocking by delaying the execution of non-critical JavaScript.
Okay, so it's like a traffic light system that prioritizes the most important content.
Exactly, allowing the initial view to load quickly without being held up by less urgent scripts.
And of course, we have Partytown, which we talked about earlier.
Yes.
It's great for isolating those pesky third-party scripts.
Absolutely keeping them from interfering with the main thread.
And then there are techniques like dead code elimination, or DCE,
Ah, yes,
which
decluttering.
helps to remove unused code from our applications.
It's like decluttering our code base.
Exactly, removing the cruft that's slowing us down.
And there are different ways to achieve DCE, like tree shaking and
It's
minification.
tree shaking and
Yeah,
minification.
tree shaking analyzes our code and removes unreferenced modules,
Right.
while minification compresses our code by removing white space and shortening variable names.
So it's all about making our code as lean and mean as possible.
Exactly. We want to eliminate anything that's not absolutely essential.
And then along with reducing the amount of code, we can also compress the data that needs to be transmitted over the network
Right.
using algorithms like gzip and Brotli.
Ah, yes, the compression classics.
So these algorithms are specifically designed for text-based resources like HTML, CSS, and JavaScript.
Exactly. They can significantly reduce the size of those files.
Compression is like having a magic shrinking ray for our web assets.
Indeed, a very apt analogy,
And for images, we have formats like WebP and JPEG XL.
which offers superior compression compared to traditional formats like JPEG and PNG.
So it's all about finding the right balance between quality and file size.
Absolutely. We want to deliver high-quality images, but we also don't want to bog down the user's connection.
And it's amazing to see how much innovation is happening in the world of image compression.
It is a very active area of research.
Now, we can't talk about web development without talking about web frameworks.
True.
They play such a huge role in how we build web applications these days.
Absolutely. They provide structure, conventions, and abstractions that can streamline the development process.
It's like having prefabricated building blocks that you can assemble to create something complex.
A good analogy.
But it's important to recognize that frameworks can also have an impact on performance,
Oh, yes. First,
both positive and negative.
some frameworks prioritize developer experience over performance,
Okay.
which can lead to larger bundles and slower load times.
So it's like choosing between a lightweight sports car and a spacious SUV.
I like that analogy.
Each has its own advantages and trade-offs.
Exactly.
And the world of web frameworks is constantly evolving,
Oh, absolutely.
with new frameworks emerging
Hmm.
that prioritize performance as a core principle.
Yeah, we're seeing a lot of innovation in this space.
So can you give us some examples of different types of frameworks and how they approach performance?
Sure. On the server side, we have frameworks like Phoenix Django and Ruby on Rails.
Okay, those are all very popular frameworks?
Yes, they offer different approaches to rendering and caching.
Right, so some might be better suited for certain types of applications than others.
Exactly. It depends on the specific requirement.
And on the client side, we have frameworks like Next.js, Svelte Vue, and Angular.
Very powerful frameworks.
And they all have their own unique ways to optimize performance.
Absolutely.
And then we have meta frameworks like Astro,
Ah, yes.
which
Well-
is becoming increasingly popular.
It's a very interesting approach.
So what's special about Astro?
Well, Astro allows developers to mix and match different rendering strategies and components from various frameworks.
So it's like having the best of both worlds.
Sort of. It gives developers a lot of flexibility to create a highly customized solution.
That's very cool.
It is a very powerful tool.
So the choice of framework can really influence the architecture of the application and ultimately the performance of the final product.
Absolutely. It's a decision that should be made carefully.
And it's a decision that often involves trade-offs.
Yeah. There's always a balance to be struck between features performance and developer experience.
Yeah, it's really fascinating to see how this pursuit of performance is driving so much innovation.
It really is, like, at every level of the stack.
Yeah, from the low-level protocols to the high-level frameworks.
Yeah, and everything in between.
It's a constantly evolving field, and as the web grows and, user expectations just keep rising,
Right.
we have to keep refining our techniques and, searching for new ways to squeeze out every ounce of performance. Yeah, it's not a one-time fix. It's really an ongoing process of optimization and improvement.
Yeah.
I think that's a really important point. And, we've seen that there's no single magic bullet
Absolutely.
when it comes to web performance optimization.
It requires a holistic approach. You have to consider everything.
Right.
From the server infrastructure to caching strategies to the way you structure your code and utilize browser capabilities.
It's like tuning a high-performance engine.
Exactly.
You need to fine-tune every component to get the best possible results.
That's a great analogy.
So as we wrap up this deep dive, what are some key takeaways that our listeners should remember as they embark on their own performance optimization journeys?
Well, I think the first and most important takeaway is that performance is not an afterthought.
Right.
It's a critical factor that directly impacts user experience, business goals, and even your visibility on the web.
If you ignore performance, It's like building a house on a shaky foundation.
Exactly.
It might seem fine at first,
Okay.
but cracks will inevitably appear.
You're going to have problems down the road.
So it's an investment that pays dividends in the long run.
Absolutely.
The second takeaway, I think, is that optimization is a continuous journey, not a destination.
Right.
The web is constantly evolving,
Mm.
and what works best today might be superseded by new techniques and technologies tomorrow.
We have to stay informed. We have to
Yeah.
be adaptable,
Yeah.
always looking for ways to improve.
So it's not enough to just learn the current best practices.
No,
We have to cultivate a mindset of continuous learning and experimentation.
absolutely.
The third takeaway, I think, is that there's no one-size-fits-all solution.
Right. The optimal approach is always going to depend on the specific needs of the application,
Right.
the target audience, the resources that are available.
Like choosing the right tool for the job.
Exactly.
Sometimes you need a hammer. Sometimes you need a screwdriver.
Sometimes you need a chainsaw.
The key is understanding the options and making informed decisions.
Absolutely.
And finally, I think it's important to remember that the web is a platform for experimentation. So don't be afraid to get your hands dirty and try things out.
Yeah.
Experiment with different techniques, measure the results, and see what works best for your particular situation.
It's all about learning by doing.
Absolutely.
And the web is the perfect playground for that.
It really is. And I think performance optimization is a crucial part of creating those exceptional user experiences that we all strive for.
It's at the heart of it, really.
So as we conclude, here's a final thought-provoking question for our listeners to consider. Given the continued growth of the web and the ever-increasing user expectations,
Yes,
how will the relationship between client and server evolve in the future?
that's a great question.
Will we see a greater shift towards distributed models and local-first principles where the client takes on more responsibility? Or will new innovations emerge that allow us to push the boundaries of performance within that traditional client-server paradigm?
It's hard to say for sure, but I think it's an exciting time to be a web developer.
It really is. There's so much potential for innovation.
We encourage you to delve deeper into the resources we've provided and to keep experimenting with different techniques, find what works best for your projects.
The pursuit of web performance, it's a challenging but rewarding endeavor.
It is.
And the knowledge you gain along the way will not only make you a better developer, but it will also empower you to create a faster, more efficient, and more enjoyable web for everyone.
Absolutely.
Well, thank you for joining us on this deep dive into the fascinating world of web application performance optimization.
It's been a pleasure.
Until next time, happy optimizing.
Happy optimizing.